So hello everyone once more. So we are going to start our session now. And what we are going to look at today is simple linear regression. And for simple linear regression, we usually follow this equation. So we usually have y being equal to mx plus c. So y is our target variable, okay? And I believe for this topic that we are covering today, you've already covered that in another session. So y is usually the target variable. And then we have our x, which is usually the feature, or the independent variable. So that's our x. Then we have m, and m defines the slope of the straight line that you are going to have. And then we have c, which is the intercept. Okay, so these four things generate the prediction that we are going to make. So for example, in a case whereby, so let's say we had an example here. So example, we have an apple that is of 500 grams, okay? And then we can have our C being equal to 20 and our M being equal to something like 0.5. So if we want to know the price of that apple, we can say price should be equal to M multiplied by the weight plus C, which should be something like price being equal to 0.5 multiplied by the 500 grams that we have for this apple plus 20, which is the grams that we have. So that gives us the price of that apple. So from this data that we have here, so you can ignore the theory part because I'll share the notes with you later, so you can go ahead and copy the third part that I'm sharing with you. So for the next part that we have here, so we are going to check our data. So this is our data. Data is not defined. Let me check the variables that we have here. Let me see. So I've defined my data frame as df. So I'm going to have df.head. And then we are going to pick two columns, and we will use those two columns for this class demonstration. So here we have age, gender, item purchased, category, amount in USD. Then we have location, size, color, season, review rating, and all those. So we are going to pick two columns here. And here what I'm going to say is, for this class example, so class example. So I'm going to use the age column, which will be my feature stroke independent variable to predict the price, so to predict the purchase amount. Okay, so that's what we will work on for this simple linear regression task. So I will create a sample data set. So we will have simple LR, so to stand for linear regression data being equal to df, then I select the age, and then I select the purchase amount in USD column. Then I can delete these other columns that we don't need. Then I'm going to have my simple LR data dot head. So that's what we have. So you can go ahead. I'll give you 2 minutes to copy that, and then we can proceed. So create your simple LR dataset, and then we can go ahead and try make predictions of the purchase amount based off the age column. Okay, so I guess we can proceed. So the first thing I'll do here is I'll visualize the data, and then what I'm going to create is just a scatter plot. So here we are going to have sns dot scatter plot. Our data is the simple LR data, x is the age, and y is the purchase amount column. Then we can add the title, so which is purchase amount in USD versus the age column. Yes, anyone with a question? Yes, Dennis.
Can you hear me?
Yes, I can hear you. Hello.
I just need to go back. I'm getting an error on that, on the simple error that
On the simple error
I'm
data.
saying.
Yeah.
Hello? Can you hear
Yes, I
me?
can hear you.
Yes. Yes. Yeah. I'm getting an error. Just hold it there for a while. Just see.
Okay, okay.
Okay.
Okay, let's proceed. So I'll run this, and we are going to see the relationship that is there between purchase amount in USD and the age column. So if you take a look at this, so this trend that we have here is not something that we can use to like fit a simple linear regression model. But since this is for demonstration purposes, I'm going to simply try use this data to show you how you fit a simple linear regression model. So once we have our data here, and once we've visualized our scatter plot, so the next thing we usually do is import the ML model that we are going to use, fit the model, and then evaluate the model. And because since this is the first class that we are having on machine learning, so we will just import the model and then feed the model to the data. Hope that's okay. So let's hope you are done with this step. If so, we can proceed. So what I'm going to do is I'm going to show you the steps that we usually follow. And here I'll add a title, and that is fit your ML model. Okay. So when fitting your ML model, so this is step number one. Step one. So define your target and features. Okay. Then we have step two, which is import and instantiate your model. So that is the ML model. Then we have step three, which is fit your model to the data. And then step four, you make predictions. Then step five is evaluate your model. So the steps that we are going to follow for today are these. So we are going to do step one, which is define your target and features. So already up here, we said that our feature column is the age column and our target column is the purchase amount column. So what we are trying to predict. So already we know what we have to define for step one. Then for step two, we have to import and instantiate your model. So which model are we going to use here? So we are going to create a simple linear regression model. And when we say a simple linear regression model, it means that we have only one feature. Then we are going to feed that model to our data, that is the data that has the target and the features. And then after that, we are going to make predictions. So let's start with step one, which is making our features. So we are going to say our X, so which is capital X, should be equal to simple LR. Then we select the age column. And then for our Y, we are going to have simple LR, and then we select the purchase amount column. So you might be wondering, why am I picking the age column as a using two square brackets, while for the target column I'm using only a single square bracket. So the reason as to why I'm doing this is because if we use a single square bracket here, if I go ahead and fit my model, I'm going to get an error, because when fitting a machine learning model, your data needs to be in a shape whereby you can add more features. But for the target, you can have it as it is here. So like you can have it as a pandas series, because for the target column, we only need one feature. But for the features column, we can add multiple features, and that calls for the need of using two square brackets. Okay, then today we are learning the simple linear regression. So what we are going to do is we are going to import linear regression from sklearn. So the library that we will be using for machine learning is called sklearn, and it has everything that we will be using in this course. So we've encountered sklearn up here where we were learning data encoding. So we can use sklearn for data encoding, but that will come in another session. So let's proceed. So we are going to have from sklearn.linear model import linear regression. So I believe you've already covered a session on linear regression, and that is using linear regression in Excel. Then what we do again is we instantiate our model. So we are going to say LR. LR stands for linear regression, and we will have LR being equal to linear regression. So this is basically how you will be instantiating all your models. Give your model a name. So this can be any name. So I can say Joseph should be equal to linear regression. So that's how I instantiate my model. But for me to like understand what I'm doing here, I'm just going to type in LR, which is the short form for linear regression. Remember when you are learning, you had a class on how to create variables. So you were informed that when naming your variables, so they should have meaning so that when you share your work with other people, they will be able to like understand what you are doing. So here we are creating a variable called LR, standing for linear regression, that has this model called linear regression. Okay, so after we've imported and instantiated our model, what do we do next? So we fit the model to our data. So to fit the model, we type in lr.fit, then we will type in our x, comma, y. That's how we do the model fitting, as simple as that. Then to make predictions, we will have our y pred, so which will be the new predictions, being equal to lr dot predict, then we predict on our x. Sorry for that. So let's proceed. Then the last thing we do is we score our model. And for regression tasks, we usually use the R squared, MSC, and the MAE. So today we are going to just use the R squared score. So we are going to have LR dot score, then we score on the X and the Y. So this will give us what we need. So like it will give us the R2 score. That's basically how we fit machine learning models. So you can see these parts that we have over here. These are simply 1, 2, 3, 4, 5 lines of code. Or if I add the ones that we have here, 1, 2, so these are 7 lines of code for just fitting the ML model. And that's the reason as to why I said that EDA is the most important part here, because ML is just 20% of what you will be doing, and you will be following this same syntax that we have here. So what I've shown you today is what you will be doing in future classes. And then I can run this. And because our data doesn't have any clear relationships, from the scatter plot we can see that these data age and purchase amount are not related in any way. So I'm expecting this score that I'm going to get here to be really low. So it means that the accuracy of this model that I'll have created here will be low, because age and purchase amount are not related in any way. So when fitting regression models, you need variables that are related in a way whereby when one changes, the other also changes. So here you can see we have 0.0001% accuracy. So it means that these two variables are not related in any way completely. But I've used them to like demonstrate how we fit linear regression models. Yeah, so that's it for linear regression models, simple linear regression models. So we will learn the multiple linear regression model in an upcoming class. So copy this, I'll give you 5 minutes and then we can have a Q&A session and maybe I can share an assignment with you guys. So something you are going to try out later on. Okay, so I think you should be done by now. So what I'm going to do is I'm going to do something quick over here, and I'll leave the rest as an assignment for you. So you don't have to copy what I'm doing here. So this is our second example. So example two. So with a data set whereby we have some relationships, and this will be using the tips data set, okay, from Seaborn. So we are going to import the tips dataset. So we are going to have tips being equal to sns.load underscore dataset then tips. We can have tips.head. So from the tips.head part here, I can check the relationship that we have between total bill and the tip size. Okay. So type in, I'm going to create a subset of the data. So I'm going to say simple LR data 2, which will be equal to tips total bill versus tip copy. And then I can check my simple LR data dot head. So from this data, if I create a scatter plot, so if I do something like sns.scatterplot and I plot the relationship between tip versus total bill, you can see we have a relationship that exists between total bill and tip. And here, if I plot a rel plot, so we can have sns dot reg plot. If I do a reg plot, you will get to see this line that is here. So whereby if you fit a linear regression model, you will expect to get something similar to this. line that we have here, because reg plot is a regression plot and it's based off simple linear regression. Okay, and this line shows you that when the total bill increases, then the tip amount is expected to increase as well. So what I want you to do is, so this will be your assignment. Mm. So use the tips data set to predict the total bill amount. So simply follow the steps. Simply follow the steps shown in class. Yeah, so that's it for simple linear regression and for today's class. Anyone with a question concerning simple linear regression and what we've covered? Yes, Michael.
So I was slightly lost at the last part of the other graph that was drawn.
This one
So
here.
what I found and what you found was not before the tips. Yeah, this one. What I had and what you have is slightly different. I'm not sure whether I can share my screen.
Yes, you can share your screen. It's okay.
Okay.
Yes, I can see your screen.
Yeah.
Okay, I can see what you have. So I've deleted the pair plot. I guess for your DF you have only two features, and that's the reason as to why you have these. So if you need yours to include all the other features, you need to check and confirm that your data frame has all the features that we had from the start. Sorry for that. Is that okay? So you can check the features that you have in your DF, and
This is what I had on
yeah, I believe you have
on
only two
my
features.
paper.